Hello everyone, this is Sting here, and today I want to share a really easy method to do this year's AIME problem 10. So let's see what the problem is. Let triangle ABC have sides AB13, which BC14 and CA15. It's not drawn with scale. I drawn pretty bad. Just don't care about this. And triangle A prime B prime C prime is obtained by rotating the ABC with about its circumcenter. In this case, it's O. So that we get A prime C prime is perpendicular to BC, with A prime and B not on the same side, which we did. So what we're gonna do is we are finding the integer closest to the area for the hexagon A prime, CC prime, BB prime. We're gonna do is with a bit thin lines. So if we connect these spots like this, in this case we'll get this hexagon thing, and we are trying to find its area. Okay. So what I do is, so here is perpendicular. I wrote it here. So I did is, I first trying to compute the rotation angle, like for sure. We really want to need this. We really want to know this, and we really need this. So let's see what sine theta is. So you could obviously find that sine theta is cosine angle BCA. So it's like this angle. Because they are in the right triangle, it should be like this. And it's really easy for us to compute the cosine angle BCA because I know the three sides of that triangle ABC. So let's do it right here. So cosine BCA is 2 times BC, which is 14, and times AC, which is 15. And on the upper side, we have 14 cubed plus 15 cubed minus AB, I'm sorry, I mean square, and minus 13 square, and skip a lot of things, which we will eventually have 3/5. So it just like compute. Yeah. So in this case, we'll get sine theta, which is 3/5. Pretty easy. So why we are computing this? Because I use a pretty nice method to compute the area of this hexagon. What I did is I connect BA prime. In this case, I separate this hexagon into the area of AA prime, BB prime. So it's like the upper one right there. And I added with the A prime C, C prime B, which is like the lower one. So why I'm doing this? Because these two areas are so easy to compute. Just let me show you why. Let me delete these. I'm not used to this. I'm used to the paint. And move these up. Okay. So let's see what the area of A prime CC prime B is. So if we use the diagonal, like the intersect formula for area, we will have, it will equal to 1/2 of the two diagonals, the product of two diagonals, which is BC times A prime C prime, and times the sine of their angle. So in this case, we have a 90-degree right here, so it should be a 1. If we plug in values, BC is 14, A prime C prime is the same with AC, which is 15. You end up getting 105. So we know this part, and now we're trying to find this part. And this part is also very, very easy, because if we use the same formula, it's SAA prime, BB prime, which will be equal to 1/2 of the product of diagonal, which is AB times A prime B prime, and times the angle between them. Okay, so what is the angle here? You will obviously find that it's also theta. Because it's the angle between AB and A prime B prime, which is just generally the rotation angle. So it will be also be the theta. So it's theta here. So it will be 1/2 times 13 times 13 times 3/5, which you will end up getting 50.7. So now we want to find the area of the hexagon, which is add them up. So it's 105 plus 15.7, which is 155.7. The closest value we round up, we will get 156, which is the answer. Yeah, it's a pretty easy method. I kind of like it. So yeah, thank you very much.